The only two solutions that existed at the time were Cosmos and Polkadot, nothing else. And Cosmos and Polkadot, we understood it very quickly technically that they only work well for their own ecosystems of chains, but not across chains.
This podcast is for informational and entertainment purposes only and is not investment, legal, or financial advice. Opinions are those of the host and guests and do not reflect any affiliated entities. Investing involves risk, and past performance is not indicative of future results. The host and guests may hold positions in discussed securities. Now, please enjoy the show. Sergey, thank you so much for joining me today. Super excited to chat with you. All right, Sergey, you are the co-founder of Axelar Network and the CEO of Interop Labs, which is a core contributor to the Axelar Network. The Axelar Network is a cross-chain interoperability protocol that enables seamless communication between different blockchain ecosystems. Previously on the founding team of Algorand, and you also earned a PhD from MIT, and your dissertation was on designing cryptographic tools for the cloud using lattice-based cryptography. All right, so Sergey, tell me about your background. You know, when you were growing up, were you always interested in tech, or was that kind of a thing that spawned later in your life?
Hey, well, great to be here. Thanks, Andrew, for having the show. I've always been interested in tech. You know, my early introduction to the technology came through my father, who was a kind of IT professional, and he was actually like a first person to set up internet back in our hometown, like in Russia when it was just starting out. So when he would like climb, 300-meter towers to set up the antennas, and then I still like routed to the banks from there. And he got a computer when I was a young kid. Was one of the first ones in class. And the game that we played, if he would try to lock it down, and I would try to break into it, by hacking the passwords and all kinds of other security measures to play some more games, and kind of went from there.
That's so cool. Wait, so tell me about this early computer. Like what type of computer was it? And also, did it have internet at that time?
No, I think the first one we had, it was actually like a laptop. I think it was like a very beefy, I don't remember the brand, but laptop that, my dad brought from work, and he was like, oh, I'm working, on some stuff there. And I think like Aladdin or something like that was like the first game that I visually remember he was showing us, like the first introduction. And then, maybe like a year later, it was like Pentium 1, one of the early Intel computers. At that point, I do think we had some access to the internet. It was, dial-up internet. So you had to pay per minute and, painfully wait for your images or songs to be downloaded. But yeah, and then from there, I would like work on setting up like a kind of a home network and things like that. I picked up a book that my dad had, was on like, different types of cabling, coax cable, Ethernet cable, and like try to hook up like a small mini network, like different topologies of networks, ring-based, star mesh, all that stuff. So it was pretty fun times.
That's so cool. So how was the, I can't even imagine using a computer in a functional way before internet, so at the early days, what were you doing on the computers besides playing games, or was it mainly playing games? Because besides that, like what other functionality could you do before it was hooked up to the internet?
Actually, the only two things I remember is like either simple games or actually easy programming, right? So, Pascal is what I remember. We were introduced at school. At school, we also got a network kind of maybe a couple of years later. And it was like Pascal. It was like, programming like, various like simple tasks, maybe like simple like robotic instructions, like to draw a tree, or you have to like, I don't know, go through a maze or something like that. I think those are the only two things I remember, right? Like, outside of the internet is like playing games and, basic programming.
When you did get access to the internet, was that like a shock to you? Or like, oh my gosh, there's a whole world I can access through this? Or was it more of a muted vibe because, there wasn't too much functionality at that time?
I think it was a little bit more muted. I think maybe, I saw it as just, okay, now like we got almost like a more powerful computer kind of a thing, right? That can do things. I don't remember being, shocked from it too much. My best memories are having to probably go and like dial up at like 2 a.m. so you can actually do something. Because like during the day, dial up is slow, right? And like, you compete for bandwidth with a lot of people because all the like early stations were very bandwidth constrained. So if you wanted like, let's say a song to actually download and finish download, you better wake up in the middle of the night.
That's crazy. Wow.
Waking up at like 2 a.m. waiting, like at the bar, and like, my parents would be sleeping because the computer would be, in the same room, and I would like quietly like wait for 7 minutes until like something is downloaded.
That's awesome. Okay, so your love of computers took you to University of Toronto eventually, right? Where I believe you did undergrad and masters, I think, right?
Correct. Yes.
And then you ended up at MIT doing your PhD in, what has to be the most applicable PhD I've ever heard of in crypto, which is again designing cryptographic tools for the cloud using lattice-based cryptography. That's insane. So can you tell me a bit about that dissertation?
Yeah, so when I was actually starting grad school, I was at the intersect. I did a little bit of networking work throughout, early, late undergrad days and like early grad school days, and I love like computer networking. I love like distributed systems. So I had a crossroad: do I do kind of cryptography or I do more, networking? And cryptography seemed more challenging, right? There's no crypto as in we know today. There was no Bitcoin. There was no blockchain, right? So at that time, it was like. The reason I actually did it is because one of the co-inventors of zero knowledge protocols, Charlie Rockoff, he was a faculty at University of Toronto, and I got an opportunity to work with him through a summer, and subsequently for some months when I was a student there. And I thought that, he was one of the best thinkers in the world, like, period, right? Like, just to see these, cryptographers think, and like, he was co-inventor of zero knowledge proofs, like, had amazing contributions to the field, and to, secure communication on the internet. Just kind of see him think through problems, through research, through designing solutions. I was very, very inspired, and I thought like I want to learn how to be, how to think and reason about problems that way. And I thought, okay, cryptography seems pretty challenging. Let me take a stab at it, kind of. And my goal for cryptography, I had this view in my head that I'm going to be doing hard problems that people haven't solved that may be applicable 15 or 20 years later, or not. Or not was a big, bold statement there. Um, so yeah, I think I really liked it because it's world where it's practical, but you also get to imagine the future in some sense, right? So we got to talk about what the secure computation in the cloud looks like, where nobody sees your data, before people start talking about those problems, right? We talk about secure, zero knowledge and like how to scale that. We talk about, selective access control to your data, when you have, millions of people trying to figure out who should access, who should not access. So yeah, it's a pretty practical, problem set, but you get to push the boundaries, for like years ahead when other technology stacks are still catching up. So yeah, I did, pretty interesting work for my dissertation. Then actually kind of joined University of Waterloo as a faculty, did continued research there in cryptography, kind of distributed systems, and yeah, kind of off went to startups from there.
Very cool. Yeah. So when you were writing your dissertation or just kind of studying and doing other work, were you ideating on potential startups that you could become involved with? And then also, was the drive to go towards startups because you're like, man, I'm learning all this incredible stuff, all this knowledge, I might as well try to apply it to a product?
Yeah, so the way it went is that kind of at the end of my grad school, I had all the papers that I knew I would finish, and so I had about 6 months to a year of effectively do whatever I wanted, right? And so I started to play at other ideas. That's when I got into the blockchain and like read the Bitcoin, Ethereum white papers, started to collaborate with Sylvia Micali on like some early designs, what ended up being Algorand, down the line. And when we wrote like the pre-Genesis paper for Algorand, it was even called them at that time, blockchain was not picking up, right? So it was impossible to find funding. It was impossible to do anything. And I thought, well, let me see what some of the things that I worked on during grad school I can do within the real world, right? So I actually started another company in like secure cloud compute, where it was a little bit more, relevant to the type of work that I was doing in grad school. And I thought those are important problems to solve. Yeah, I think my motivation was to kind of learn more, explore more. I always, like to have free environments where I get to kind of build from scratch. That's maybe one of the reasons I so like academic environments where you don't have a lot of corporate constraints in some sense, and startup environment is where you get to challenge existing products, ecosystems, communities. Yeah, so just I don't know, felt fun to to try some of the ideas, and off I went.
That's great. Okay, so you said you were having trouble raising with Algorand, which is so crazy for for us now talking about it in 2025. Tell me about those early days of Algorand. You met up with another co-founder, and what was the thought and thesis around it? Was like, okay, we see Bitcoin, we see Ethereum, we can do XYZ better, or what was the initial ideas around that?
Yeah, the original motivation was, yeah, we see Bitcoin, we see Ethereum, sort of not very efficient. We're gonna see scaling problems as you continue applying it to more transactions, right? More computation intensive workloads. Kind of being technologists first, we kind of started to think about those problems. How can we do distributed ledger better, right? And yeah, that was the original motivation, what kind of led to Algorand, but also a lot of other consensus, projects. Some of them came out of academia, right? Like Avalanche, there was Near, of course, Solana, like all of those competing blockchains that try to just do better at consensus and do better at execution.
And so, tell me more about the Algorand journey, because you're a co-founder, right? Essentially, so tell me about how it went from, hey, here's an idea, to, hey, we're having difficulty finding funding, to, okay, now we're going to get funding and launch this thing. Or tell me about the whole kind of journey.
Yeah, I mean, the journey was that we had the early white paper. We filed a few patents around it with Silvio, and then so I didn't know anything about business at the time. So Silvio tried to raise the money, and he's like has a pretty good network. We tried to sell it to a couple different vendors. I remember Silvio scheduling a call with like Italian post office, like telling them the benefits of blockchain. Maybe not the most efficient go-to-market to have one of the most bureaucratic, institutions be your first customer you're trying to do. But yeah, we tried different things, and I think it wasn't really kind of catching things, and I effectively told to Sylvia at the time, like, hey, I'm happy to kind of continue advising on the side and like helping, but like I'm gonna try other things in parallel, right? And so I started my own company in the secure cloud compute, and then I went to the university for a few years. And then, I think 2 or 3 years later, then it was 2017, 2018. Then things start picking up in crypto again, right? We saw a flood of funding, of course, all kind of ICO craze. And that's when Silvio found first investors, right? And then myself, and then a few other students, including my co-founder now, like Yorgos, who worked with Silvio like throughout those 2 years. Or 3 years on the background, helping continue to iterate over the design of the consensus, scaling properties. We're all kind of came together at MIT, got a small office and went from there.
Very cool. Okay, so Algorand was not solving interoperability. It was just becoming just a better L1 essentially. So what was your thought process, or when did you first come to the conclusion that, okay, interoperability is a really important problem that I want to be working on? Because back in the day, I mean, still today, I should say, we had Polkadot, Cosmos, Layer Zero, Wormhole, etc. There's a lot of it's a huge problem. Everyone knows it. But what were your thoughts around that? Because obviously there's these other solutions out there, and were you just like, man, these people are doing it all wrong. Here's how I would do it. I need to pursue this. Or tell me about that kind of path.
I mean, the only two solutions that existed at the time were, kind of Cosmos and Polkadot, right? And nothing else. And Cosmos and Polkadot, we understood it very quickly technically that they only work well for their own ecosystems of chains, but not across chains, right? So remember like early conversations with, Cosmos folks that were telling me about how the, like client technology works, like for IBC and things like that. And I had a hard time understanding how this could scale outside of Cosmos, right? I'm like, well, nobody's gonna be able to write these, like for us to integrate it in Algorand, it would take essentially a rewrite of the whole Algorand blockchain. So just kind of engineering wise and technical wise, it was clear that that approach would be very hard to scale outside. And Polkadot didn't even try those things. They were like, okay, our interoperability only works within our parachains, right? Like we have no goals of extending it outside of it. So for us, it was clear that those solutions would not work. It was definitely one of the big questions that investors were asking in the first round. They're like, "Oh, like Cosmos is going to launch ABC, and what's going to be the need for it?" And remember, like very deep, like long threads with some investors where I would explain why I don't think that technology would scale. And I have a lot of respect for the Cosmos team, for ABC team. I think they've done amazing for the ecosystem, but like technically, I think the protocol has kind of scalability gaps, which I think some teams are trying to address. 6 years later, I think it's still not fully addressed. So I think our first white paper essentially actually defined the way that applications should talk to one another across chains. I think we put a diagram where we had like two applications and they send messages to one another, and we didn't quite know exactly how that would look like, fully fleshed out yet, but I'm pretty sure we kind of defined that notion. And then, some of the protocols kind of followed, including like layer 0, right, and kind of a wormhole and, sort of entered the space. But for us, it was clear that the ecosystem is going to continue scaling horizontally, which means many L1s, many L2s, and many layers. And that comes with fragmentation issues that have to be addressed, right? And so interoperability is a very critical component to be able to address those fragmentation issues.
I guess, what are your takes, or what's your take on the current newer players in the interop space, layer 0 and wormhole? Do you think that, because I always felt when I first learned about Polkadot and Cosmos, I was like, oh my gosh, this is amazing. It's going to solve these problems. And then I was like, oh wait, it's interoperable if you build on them essentially. So I was like, that doesn't really make sense. But with layer 0 and wormhole, do you think that there's been a massive improvement? And do you think that obviously what you're building is even beyond that?
I do think those improvements, I mean, you have to look under the hood to understand what are the security properties that interoperability provides. So in some sense, it's very easy to provide very centralized security and very centralized interoperability, right? Like every exchange is an interoperability hub across chains, right? That allows you to swap tokens. You just trust it, and then you get FTX at the end of it, right? So I think that's one of the hardest parts to solve for interoperability, is really making sure you have a decentralized stack where anybody can join, anybody can participate in the security, anybody can validate transactions, and we're the only ones that are properly doing it. But yeah, definitely, I think the technology is becoming more and more mature across the category, and finding more use. And I think the next wave of applications is going to be, chain agnostic, essentially, right? Or next wave of assets that are issued is going to be chain agnostic, which is going to be very exciting, I think, and will solve a lot of fragmentation problems.
So, in your opinion, what is the primary differentiator between Axelar and these other solutions? You mentioned centralization, which is a big one, and but it also you mentioned that you have a more open, decentralized network that it's more trustless. So just in your opinion, what is the big differentiators between Axelar and these other players?
Yeah, Axelar is the only fully permissionless proof of stake powered interoperability protocol, right? So what that practically means is that on the security layer, there's like over 75 validators, all open validator set. Anybody can join, participate. We have one of the highest like Nakamoto coefficients across all chains, period. I think you need like to compromise like over 35 nodes, to break the security of the network, which more than most layer ones themselves. Because it's a chain, it actually has programmability within its smart contracts. And what it allows to do is it allows developers to extend it and build their own connections, right? So you don't have to going forward kind of come and talk to us. You want to interoperate with the Axelar kind of network of networks. You can instantiate your own connection, and we have over 70 teams that are building connections to all the major ecosystems, right? Ripple, Stellar, Solana, Sui, Aptos, Bitcoin, and kind of the list goes on. And it's not done by us. It's actually done through we're one of the contributors, but there's a lot of teams that are building their own connections. And kind of the analogies that I give around this is that, during the internet and like all those kind of early days of the internet evolution that we talked about earlier, the protocols that scaled were the open protocols like TCP/IP, right? Where you had an open standard where anybody could build their solution around and anybody could contribute to, and not vendor solutions, right? And you had a competition from vendors like even like, Microsoft, Cisco, Apple pushing their kind of a vendor interoperability protocols, but none of them scaled because you could not build an ecosystem around those, right? It was like a solution, give me an NDA, give me a contract to be a part of this. And Axelar compared to everyone else is really, it's a chain. It's just a chain designed for interoperability in mind, and with interoperability functions that kind of people extend in now.
Can you give a basic example of, I'm using an application on Ethereum and I want to use something on Solana, and I can soon, or maybe today, go through the Axelar network to do that?
Yeah. Let's talk about like two applications. The simplest one would be actually like token issuance, right? So as an example, a lot of early ways to issue tokens are very specific to one chain. And then you try to figure out how do you bridge it to other ecosystems, right? And you create these like wrapped assets. You use like one bridging protocol for this, one for that. Your liquidity is kind of disconnected. You manage, maybe liquidity back and forth. So very painful experience. So there's, one of the products we have is called like interchain token service, where you can take a token and using like, Axelar and message passing, essentially deploy your tokens on like 70 plus chains with one click, period. Right. And what that practically means is that your token has, consistent representation everywhere. It has consistent, naming. So it's the same name, and when you send it back and forth, it automatically kind of rebalances and sort of burns on one chain, mints on the other chain. You don't have to look for bridging, protocol support. You don't have to create wrapped assets. So it's a very clean way to issue your tokens across all the chains, right? And, partners like stablecoin issuers, RWA issuers, even like meme coins, they're all looking for ways to have their token be accessible across all chains. So that's one way. And then the second is more what I would call like interchain native applications, where suppose you have a token on one chain, but you want to like deposit it in a decentralized exchange or, or like an NFT application on another chain, right? Kind of historically, that would involve you taking a token, if it's interchain native, you can move it to another chain through like Axelar to the destination chain, switch your wallet, and then like deposit in the application, right? But you can now with Axelar automate all of that flow in one transaction from the wallet, right? So you have a token, the user goes to the application front ends, and they just click, hey, deposit this token. And even if this application lives on any other chain, all the backend transfer, deposit function, wallet switch, gas payments are abstracted away from the user, and they don't have to think about that, right? So this is effectively what we do is we just connect, users from their wallets with their token directly to the application, no matter where the application or the token lives.
Okay, so example, I want to launch a meme coin on Pump Fun.
Yeah.
Andrew meme, whatever. And right now it's just on Solana. So if I use Axelar Network, I will launch it on Pump. Like, explain that kind of flow, because I'm still a little confused there how that would mechanically work.
Yeah. So let's say two examples. One, let's say your token doesn't even exist yet, right? And then, you would go through this kind of a protocol that we built called interchain token service. And you just literally specify what chains you want your token on. And then on all of those chains, let's say like a version of ERC20 or equivalent for the underlying VM gets deployed. And it's a standard token, except that it has the same name, it has the same address, and it has a few extra functions that allow you to send that token back and forth across chains, right? All baked in the same contract and the same configuration. So that's one way. The second way, if you already have a token, let's say you have a token in Solana, right? And again, you can go through these portals and products and say, hey, now I want this token to be almost like mirrored, right, on like 70 other chains. Then you specify which chains that you want, and then we look at the representation of the original token, and then you get a new deployment of it on all the other chains with those cross-chain functions like that allow you to mint and burn and send it across the chains.
So, okay, will there be price discrepancies between Ethereum and Solana and all these different chains? Well, maybe it's trading higher on ETH than it is on Solana, and how do you solve for that?
Yeah, so we didn't deal with the prices themselves. What we do is we guarantee that you have a representation of the token that's consistent and identical on all the chains, right? And yes, it could be the case that, on one chain, there's a deeper liquidity, maybe has a better price. On another chain, if you work on it, maybe it has, lower liquidity and maybe a different price, and then the markets themselves usually figure those things out. But to that point, this is exactly where the benefit of fully interchain native applications comes in, where you don't have to create liquidity on all the chains, right? So imagine a new world now where you just want to be able to trade this token, right? Yes, the token itself could live across, 70 chains, but you want to be able to trade it, to your point, in the most capital efficient way, right? So the way to instantiate that using primitives like cross-chain message passing is to have the liquidity of this token on any chain that you want with the deepest property, right? And then change the way the wallets interact with it. So when the user submits a trade transaction, it doesn't automatically gets executed maybe on that chain, but it gets routed under the hood into the chain that has the deepest pool where you aggregate everything. It gets automatically swapped for the token of destination, and the token of your choice then gets routed back to your chain where you initiated the transaction from, right? So from your perspective, you don't care whether the swap actually happened and it happened on the chain with the best properties, with the best liquidity. But your UX is very, very simple. You never had to do that discovery yourself. You never had to do the bridging of the token. But the user of Base as an example, because you like, maybe, some of the on and off ramps, maybe the wallet experience and things like that. So this is really the future that we're entering, right? Where application could live anywhere. And in most cases, you just need to have one instance of that application. You just need to have connection of that application to other chains and other wallets to kind of, facilitate on and off communication.
That's awesome. Okay. So are the validators in the network, are they checking the different chains to see, which, like, so you have like a base validator and a Solana validator, et cetera, or how are the validators functioning within the network?
Yeah, so Axelar validators, to your point, kind of collectively monitor all those different chains, right? And so you can think of them as being kind of a, sort of a airport, hub controller, right? That says, okay, these are all the different chains, and like these are all the different flights that are happening across those chains. These are the users that want to go cross chain. And then they pick up those cross-chain transactions and events, they validate them, and then they execute corresponding actions on other chains, right? So it's almost like a big, airport hub with kind of air traffic control in the middle.
And the validators, they don't have to specialize on looking at a specific chain. They can look at every chain.
That precisely is actually the challenge to build something like Axelar, right? And I said we already connect a lot of different chains, a lot of different consensus mechanisms, a lot of smart contracts. So one of the big differentiators is, as I said, like we have smart contract language on Axelar itself that allows you to program very easily functions to to understand the different chain. The way we design it is that you need very little understanding of the chain itself. Like you never have to understand its consensus. You have to understand like very specific opcode formats or things like that. But there's like a lightweight of understanding you need to be able to, of course, read and write to that chain at the very least.
Are there going to be issues down the line? Let's say in like 5 years when there's even more chains out there, and like will these validators get bloated, therefore slower and more difficult to operate, or is that not an issue?
Yeah, no, great question. So we have a pretty deep kind of a scaling plan. It's actually mapped out at Axelar community forums. But essentially two things. Axelar has a model now where you can set up additional validator sets, right, to support other chains. So as an example, even if like your chain is so maybe it's very computationally expensive, right? Then maybe you can spin up its own like validator set of like 50 nodes to just manage that, or you can have validator clusters that are doing repetitive functions for a lot of chains. For instance, for L2s, right? For all the L2s, like in the optimism world, they're all the same. It's all the same code base. So maybe you have its own validator set to manage all the L2s collectively. And yeah, so we have actually a very efficient model to scale the validators kind of horizontally. The tokenomics scale quite well for that to reward them and pretty favorable. That's one. And then two, we do have certain chains that are starting to get more like client support, right? So as an example, there are like zero knowledge chains, right? And zero knowledge by itself has essentially like a baked in like client, right? That is a zero knowledge proof that's posted typically to Ethereum settlement, but you can take that and post it on Axelar itself to understand that zero knowledge chain and be able to read and write messages from it, right? So we're starting to see that again, like back to my scalability constraint, those are, challenging engineering, typically stacks to work with. And they only scale in this hub and spoke model like Axelar. But we're starting to see some of them and some of the integrations that leverage that doesn't require external validation, right? For that chain, it just parses this proofs like from zero knowledge protocols directly.
What's the primary function of the AXL token, the Axelar token?
Yeah, so as I mentioned, like Axelar is a chain itself, right? So kind of the token is used for all the gas payments on Axelar. So every time there's a cross-chain transaction, there's a gas paid to the Axelar for processing it. It's used as a governance token, right? So all the on-chain activity, upgrades, new network additions go through the governance and like the community votes. And it's also used as security mechanism, of course, right? So people stake the token, they elect the validators. The validators that do well, of course, get more voting power in the network. So yeah, it's a kind of a governance, security, and utility. And the new actual use of the token that was just added through this permissionless integration framework is that, yeah, if you want to have new chains being supported, then in the past, there would be an on-chain inflation that's introduced to incentivize validators. So that's no longer the case. There's no more inflation that's being added to the network, but instead, the chains that want to integrate, they need to like explicitly reward validators to do that by, go and acquire maybe XL somewhere and put it in a rewards pool explicitly, and then those rewards flow into the validators, right? So that's like a new utility that was just added, a couple of weeks ago.
Very cool. All right, so security. You did mention you need 35 nodes in order to break the security, but what are some other, hypothetical security concerns that could arise, or that, where do you see any sort of potential weaknesses or anything like that?
Yeah, I mean, like, security is something we take very seriously, right? And you just have to be paranoid across the stack. And I think we're definitely one of the most paranoid teams. I view it as a three-layer approach that we have to execute on. You have to have the right design, and the right architecture. Without it, nothing could work. If you have a centralized system with a few nodes, nothing, is going to save you, right? Like you just compromise a few nodes. So you have to have a decentralized system. You have to have, we have things like quadratic voting on the network, right? To improve like Nakamoto coefficient and things like that. So that's the base. Then from there, it's like, how do you actually build things and engineering practices, right? So as an example, everything we push gets tested many times, or unit tests, end-to-end tests. We run audits, and I think we've done probably like close to 100 audits at this point, frankly, right? Like, so every component that we ship goes through, the audit phase with a few very reputable community players. We have a multi-million-dollar back bounty, so if, could white hat, hackers or ethical hackers find something, we encourage them to let us know, right, and kind of address it proactively. And there are things like, rate limits across the stack. So, different connections that are added through the network, they may have, essentially like rate limits that prevent catastrophic disasters, right? So if there's an exploit, okay, maybe there's an attack for, like a few million, but, you're not draining all of the capital, you're not draining all of the applications that depend on that connection. And actually having a hub and spoke architecture is very efficient because it allows us to isolate these issues, right? So if you have like one chain or one application, one chain that sort of misbehaving or was corrupt, you just kind of pause that connection, everything else continues function. It's a hub. In comparison, a lot of our competitors, they run pairwise protocols, right? And in pairwise protocols where everything is interconnected, one of these things go down, like you have to go and like talk to everybody to update everyone else, and like the paths and everything else is very intermingled. So it's impossible to manage those networks in practice as they scale, for years. So yeah, engineering and like having these types of, threshold mechanisms, practices across the stack is very important. And then on the application layer, there are always things that we encourage application developers that leverage our stack to do. So as an example, a lot of applications want to have upgrades, right? And what's the typical answer to do an upgrade? They say, oh, I'm going to have like a multisig for upgrade function, right? And then multisig becomes, a security, a choke point, and we've seen all kinds of, attacks around them, right? Where people like lose keys, compromise, founder keys and things like that. What we have as an example is a fully decentralized kind of governance framework on top of Axel that you can use to orchestrate your upgrades, right? So what that means is that instead of relying on 2 or 3 keys, you can actually put a governance vote. Let's say, hey, I want to have an upgrade where all the token holders, either of your chain or Axelar themselves, could vote to authorize an upgrade function for you, right? So then you're not relying on like a centralized multisig to do those. You're relying on governance from day one, and you can piggyback almost like on Axelar as a governance framework for doing some of it, right? So we have this interchain governance orchestrator framework. It was actually leveraged in Uniswap for some of the governance work for expanding their contracts to other chains. And that's exactly what they do. When there's a parameter upgrade or a function upgrade, they want to make sure it goes through the governance, and those governance decisions are communicated, cross-chain, as opposed to having like centralized multisigs to execute them. So those are the types of application layer on the third layer of the stack, services and tools that we always, kind of work on and encourage the developers to leverage.
Very cool. All right. So what are the primary use cases you're seeing today of people using Axelar? And then going forward, what do you expect? How do you expect that to expand?
Yeah, the biggest use cases we're still seeing around interaction with tokens, right? So either launching the tokens across multiple chains, swapping tokens across multiple chains, or using the tokens, indexes and things like that. We're seeing a pretty big explosion in the kind of RWA asset classes, right? So stable coins, tokenized treasuries, bonds, and things like that. There's a new category of use cases that we're seeing. And with it, we're seeing a lot of institutional interest as well, right? So we've done some pilots with like JPM, with Apollo, with Citi, MasterCard. You can see a lot of the cases for those issuers that kind of think ahead. They always want to make sure that they don't launch on one chain and get stuck there, right? Either have their private chains that they want to launch an asset on and have it interconnected to everything else, or they by default go to, public chain to launch their original assets, and they want to have wallets from other chains access it, right? So those are the big use cases which I think we expect to see over the coming years to, become more institutionalized, more regulated, right, with more favorable administration now entering. And yeah, then, I think from there, things should pick up quite a lot.
On the crypto native side, are most of these issuers of the tokens, are they meme coins? Are they projects that want the liquidity and communities of multiple chains? Or what are the types of crypto native folks that are active on Axelar?
All of the above, right? So we have stable coins. We do have meme coins. There's actually a project called Printer that just like launching kind of a meme coin launchpad across Axelar and all of the interconnected chains. We do see some like AI coins these days, right? And like they want to have distribution to other ecosystems. But we're also see projects that have long like product market fits and big assets that want to have distribution. So as an example, we're working with Ripple, right? And Ripple, of course, has their, XRP, right? And, they have some other initiatives that are working through, and they want to have connectivity of those major assets with other chains, right? So once that connection is activated, all those assets are going to go and be interconnected. So yeah, pretty much like everything across the stack that I think wants to have a distribution to multiple chains, needs support from players like Axelar.
Very cool. All right. So this seems extremely technically complicated. What has been the biggest technical challenge that you faced while building Axelar?
I mean, I think the biggest one is, of course, like insurance security is right? Like we obsess over it. But I think, once you work with, a few chains, it's like all fine. Once you're at that scale where you have dozens, and like now we're approaching like 100 plus soon, the scale of just supporting the infrastructure stack and like dealing with chain like upgrades themselves. It becomes like, an engineering operational challenge. So every time there's a chain upgrade, of course, everything needs to be upgraded, right? Like node software needs to be upgraded. Again, like we have a benefit that we operate a hub that only like one validator set needs to upgrade, and like you're done. Back to the point of like if you had like a live client of that chain that resided on like 70 other chains, you would have to go and like upgrade on every one of the 70 chains, which is completely unusable. We only need to do it once in some sense, right? So yeah, that really helps. But at that scale, when you're 100 plus connections, those kind of a practical operation engineering challenges, they take some time.
So, operating kind of this, being a contributor to a chain is such a unique, like not many people in the world do this, right? It's like, most people work in regular companies. A lot of people work in Web3 now, but even Web3, a lot of them are just like regular companies. This is kind of a different beast where it's like this, it's like, it's a decentralized, uh, foundation and group and people that are working on this. What are some of the unique challenges of that? Just kind of just operating in this decentralized Web3 way.
I mean, honestly, I find it to be like incredibly like rewarding. First of all, like before we get into challenges, because yeah, I don't know. Like one of the reasons I like blockchain technology is that you get to people that contribute from all over the world with all kinds of backgrounds and all kinds of skill sets, and like they almost like trying to come to social consensus to run a technical consensus, right? So I don't know about you, but like I find it just incredibly rewarding to be a part of these communities, right? And I think many people are that are in the space, of course. Would Of course that comes with its own layer of challenges, right? Where you have opinions and thoughts and like coordination, along the way. One thing, as an example, I always said that the actual network and security needs to be decoupled from cross-chain like messaging API. Like messaging API is very simple. It's like 5 fields. It's almost like what is the header of your envelope, right? When you send mail, right? Like okay, pretty easy to say, right? Those 5 lines. But because of just many interoperability protocols, like people like had their own versions of like what's the order of those 5 lines, like what are the details you should add, around them. But like I always said that we should just standardize that. There's no merit in that in some sense, and but where the actual value is, how do you process the messages? How do you provide security? How do you provide scalability? How do you provide reach? Of all the networks, and like differentiate on that. Yeah, of course, like people didn't quite get it. Now in Ethereum community, everybody is buzzing about this, right? And like because they're trying to figure out how do L2s talk to one another, and it's like the biggest problem for them. So I'm actually very happy that we started a collaboration with OpenZeppelin to standardize semantics for cross-chain. And I think the standard that we have now being used as the base across all the L2s to standardize the cross-chain message semantics. There's a regular recurring call that the Ethereum community has, and like our team and like opens up when we participate in and providing like our thoughts. It's not easy, right? Like these are the types of social consensus you have to come together about. And I think we're fortunate to partner with some folks like Expresso, Open Zeppelin to kind of support and say, hey, like let's just agree on these API semantics. It's going to be better for everybody because everybody can then build their tooling and networks and ecosystem around it. So I'm pretty happy that we're actually now ahead on that initiative, but it was not an easy way to get this across the line.
It's very cool. All right, so I want to learn about user acquisition. Are you, because every network needs more users, and more users leads to more network effects, etc. How are you thinking about user acquisition? Are you thinking let's target the crypto natives, let's target the institutions, a combination? How do you think of that?
Yeah, I mean, for us, the users are essentially like developers, right? So developers that either build applications or, maybe they build an application and launch as associated token, right? Yeah, it's everything from, crypto native, institutional. We did some early pilots over the last few years. They were very cautious, right, about the whole space and like what they can do with it. I think now, last few months, we see an increased activity across the institutions, and So I think that's going to be, a very exciting initiative to actually get some real assets tokenized and, next level of volume and scale. It's anybody that's building in the space, and I think they're pretty exciting initiatives on both kind of a Web3 native and institutional side that are happening now.
Do you have to go to these developers and kind of pitch yourselves because, hey guys, you should build on, you should make it interoperable from day one versus build on Solana, build on ETH, et cetera. Or how was your approach when speaking to specifically to crypto natives? Because I think institutions, it's a kind of a no-brainer. Of course, you want the interoperability, but for a crypto native, maybe I'm like, no, I want that Solana degens, right? So how do you approach those crypto native?
Yeah, so it depends on the project. And by the way, I had I posted I think on Twitter at some point, just like a mental flow chart that I think developers should use. And I always tell them pretty transparent, hey, if you don't know what you're doing and you don't have a product market fit and you just need to iterate fast and try to figure out if there's anybody that will use your stuff, just launch on one chain that meets your needs. Okay, launch, get some users, make sure actually somebody wants your product, right? Um, I think where we find most usage is kind of a people that either know use cases that have a product market fit, and they either looking to scale or they're looking for a unique distribution, right? That doesn't just depend on grants from one foundation and things like that. And but the applications or tokens that have a product market fit, their phase two is always scale, and that comes with going cross chain. But the other big thing is that I found from the last kind of a cycle is that a lot of developers actually fed up betting their reputation on one chain, right? Because we see ups and downs with those communities all the time. Today Solana is great. Tomorrow it's FTX chain and it's banking, and my application doesn't have users. And today it's great again. Um, you know, L2, this Arbitrum was awesome today. Tomorrow it's a little bit less awesome, and I need to go somewhere else, right? So there's a pretty big cluster and groups of people that want to go multi-chain. They don't want to be tied up to an ecosystem, and they want to be able to leverage good activity that happens on those chains at the time when it happens, right? If today something amazing happening on Solana, you don't want to be thinking about your deployment there today. You want to be there today, right? And so we're finding more of those developers in that mindset. If you actually look at Electric Capital Developer Report that they produce every year, very consistent. The number of multi-chain developers keeps on growing, right? And keeps on growing as a fraction of all developers very, very rapidly. And I think, being there for the distribution, for the, for your application, not having a, kind of a fixed mindset of one ecosystem actually puts you in a very big advantage compared to everyone else. If tomorrow is Base is going to have better on and off ramps with Coinbase, you want to be there, right? If Solana has, its own growing activity with its users, you want to be there, right? If XRP starts getting some more real tokenization and securities, you want to be a part of that liquidity as well.
All right. So I guess building off that point, how important is the narrative? Because, everyone says, the narrative is kind of the primary value driver in a lot of these networks today. I would argue fundamentals is still kind of underlooked, but how important is it for you guys or for you to kind of strike the narrative? Hey guys, spread the thesis that interop is so important, which it is, but I feel like I don't hear it as much as I think we should, because it is a major problem. Tell me about the narrative.
Yeah, no, I mean, in all honesty, it's a little bit of a, I guess, challenge, right? For our category, it's this boring infrastructure, stuff on the back end. But what we have tried to do, at least as Axelar, is build a network and a technology that's going to be here for decades. Okay, I always tell people, especially early founders, many of them were hey, this is hot today, I'm gonna go and do something. Okay, if you do something and something that's hot today, by the time you launch, it's not gonna be hot. So if you're in that game where you want to be fast and kind of get some whatever returns or get some interesting applications for the next 12 months, you can play those games. What I'm excited about is building infrastructure that will be here for decades. Interoperability stacks, once they're there, They're not going anywhere. Like the legacy protocols on the internet that we, have designed and as communities and like researchers decades ago, we're still the ones that we're relying on now, right? And now imagine the world where those protocols were kind of tokenized, right? And like had their own networks and had their own communities. And so that's effectively what we're doing, right? Is that kind of rebuilding the, foundational TCP/IP layer for Web3 stack, but it's more open, it's more secure, it has its own kind of community and token holders, right? And governance that you can, fastly rely on. And that's value will be there, 3 years, 5 years, and 10 years from now, because of how foundational that is. Yeah, there will be a lot of applications that are built on top of it. But this is the value that we built. And like in all retrospect, by the way, if you look at it, the value goes up and down the stacks. But now I think with more AI and actually software, it's almost like it's gravitating back to the foundational infrastructure, right? Like NVIDIA is the hottest thing in town right now. Nobody thought CPUs and GPUs would be the hottest thing in town ever, right? But that's because a lot of the software is being now, and a lot of like SaaS is being intermediated by the AI. So what do? You go all the way back to the bare basics and the infrastructure that facilitates that. And so this is the world that we live in. Like yeah, there's going to be a lot of noise and a lot of movement. We're at the ground foundational layer, which if we tokenize, trillions of assets with major RWA issuers, through our protocols and our infrastructure, it's not going to go anywhere.
And then also, it's funny because by nature, you're not like, it's designed to not be tribalistic, versus crypto today is so tribalistic. It's like, oh, this is my chain. I'm going to do my thing on my chain, and your chain sucks, etc. And you're like, no, like that doesn't make any sense, which it doesn't. And but yeah, no. So it's a tricky thing with the narrative. But you're right about the long-term prospects and long-term vision of where blockchain, crypto networks, et cetera, are going to go. It has to be interoperable. There's no way we can all use Solana or Ethereum or et cetera, right? So makes sense. All right. So looking forward, we'll call it 5-10 years. Where do you want to see Axelar?
I mean, I want to make sure Axelar is the default, of course, interoperability layer, right? I think we'll build a very amazing stack and, network in the community. So making sure every chain can interoperate with Axelar and its a suite of protocols as easily as possible. And yeah, kind of to your point, like make sure the user experiences are better, right? When we talk with interaction across the web today and internet, it's all about us, open up our browser and just having this video call, right? Under the hood, layers of interoperability stacks actually facilitate that. We don't care about them today, right? I think in crypto, we still have to care about this interoperability infrastructure as both developers and the users, unfortunately. And I want to make sure that that's not there, right? In the coming years. And the other big thing, I want to make sure that the systems outside of Web3 are also interoperable with Web3 itself, right? So whenever we're talking about tokenization, yeah, of course, blockchain is going to be an enabler to make it more efficient and more, globally settled instantly. But there's a lot of on and off ramps with traditional institutions you have to have. There's a lot of, APIs you have to support with legacy systems. So yeah, we want to make sure we interoperate across those stacks as well.
Very cool. All right. I want to move a little bit away from Axelar specifically and talk about more broader topics, but meme coins. What is your take on the meme coin meta that's been 24 kind of going into 25?
I mean, I think it's fun, right? And it has its own community and it has its own product market fit. I kind of play a little bit here and there, but I like to, yeah, I mean, I think as a distribution channel, right, for crypto. In some cases, these meme coins are sort of becoming more of a, replacement for NFTs and collectibles, which I think it has its own, product market fit as well. But yeah, we'll see kind of a long-term, impact of them. I do think it's going to be a market segment, definitely. But as in crypto, we focus on one thing at a time. And that was the thing to focus on last year.
So now, I guess this year, you could kind of argue AI agents have taken a lot of mind share from meme coins, even though it seems like AI agent mind share is trending down already. But what is your take on the AI agent meta?
I mean, I had a tweet on that where I put like an intersection of AI and Web3, and like in a Venn diagram, two big circles with very tiny intersections. So I think it's there are real problems that both stacks benefit from one another. Around payments, around verifiability, provenance tracking, and things like that. Maybe AI agent can automate some functions that are complicated now in the Web3 infrastructure. But yeah, from a technologist perspective, I always think about what is the real value that those things bring. Trying to understand the use cases. There's a lot of agent frameworks these days, right? So it's still trying to differentiate across some of them. But yeah, I do think there's naturally going to be an intersect between AI, and crypto, Web3, AI, and any stack for that matter, right? And I do think there's a definite need for having blockchain kind of crypto rails be powering some of the AI activity. We'll see some more kind of real products around that. So I'm looking forward to that.
So besides interop, what use case do you think is severely underrated or not talked enough about today?
Even like 8 years ago when we were working in Algorand, I always thought like WhatsApp should have, send me a coin like feature, right? Directly from your wallet. We're still kind of carving those paths. I like what Signal is actually doing with introducing payments, right? And blockchain technology directly into the Signal app. I wish to see more of that, from others. And I think we will, right? And I think when those apps start directly interacting with blockchain networks.
All right. So what do you think is the biggest trend in crypto over the next, we'll call it 3 years, but obviously not interop?
I think it's going to be new asset classes that are more institutionalized that, will enter the space. And, unfortunately or fortunately, I don't know how you want to look at it, these are going to be maybe not as IPO trendy, right? These are going to be probably more real, but will bring like more, real dollar value to everything. But I think that's the next wave that we can expect is like really see benefit for traditional financial systems using blockchain technology, and I think that's going to be a huge unlock for what we've been building, for decades. And I do think we're going to see that for the next 3-4 years.
Yeah, I think Apollo they tokenized something on chain yesterday, or they announced it, and the APY is like 11.35% or something like that, which is like, I mean, that's amazing, right? It's so cool. It's Apollo, which is like a massive 700 plus billion AUM firm. So that's really crazy. But then also I'm like, man, I wonder what crypto degens are going to be like 11.35%. Like, nice. You know what I mean? Like they want to go to use something. It's like, 500% or whatever, but it's for a different audience. So it's very cool.
Imagine global distribution to these financial instruments, right? Like what it would do to them. Like, I speak with a lot of even crypto, native people, and they're like, I have no idea how to, I don't know, like buy like a US treasury, right? Like if somebody were to give me, access to it from a wallet, like I would do it. And a lot of them are international, right? Like a lot of them like don't have, your Schwab accounts and like Fidelities and things like that, or like they just don't want to deal with that. So I think it's just gonna take the economies, to the next level once these instruments become globally accessible.
Totally agree. All right, Sergey, it is time for the closing questions. All right, what book, movie, podcast, TV show, etc., some piece of content, which piece of content had a major impact on you?
You mean in terms of categories?
Yeah, whether it was like, some book that you read or some movie you saw or some podcast you listened to, you're like, oh my gosh, this has such a big impact on the way I view XYZ.
The Chip War was a pretty good book. Last year and like understand how that history, kind of played out. Crossing the Chasm is another book that kind of recently been browsing, but like read maybe a couple of years ago for the first time, that I thought was pretty interesting. I'm a fan of a lot of like Naval's kind of tweets, and like I think there's a book somebody compiled with his stuff more recently. It didn't resonate some of it like years ago, but like I think as I don't know, get more senior or older, I kind of resonate with some of it and like can really relate a lot. Yeah, maybe those are some of the things.
Those are great. All right, you cannot work in crypto. What would you be doing?
Well, my original path was to do academia, that I kind of set out. I think it's still fun. I still do some work with the, University of Waterloo and like supporting the club there and the students. So I still like that. It has a, heavy bureaucracy hit that you have to be okay with at times, but other times working with students and like doing research, I really love. Yeah, I mean, maybe doing another startup, and some other category. There are definitely always interesting problems in technology, and robotics and energy that, you know, I find interesting. So, yeah, not sure what I would be doing there, but I think hopefully building something useful.
Awesome. All right. You could go back in time and tell yourself one piece of advice before starting your entrepreneurial journey. What would that advice be?
Take more breaks.
Super breaks.
I think it's a mentally, strenuous journey. You want to run it for a long time. I think at times I go all in, and that kind of impacts potentially even like some decision making in the short term, right? Or kind of your tolerance in the long term. Yeah, just kind of being a little bit more mindful of kind of rest, energy, pacing yourself, and like emotionally detaching yourself from certain things. I think those are things like I had to learn along the way.
That's great. All right. Last question. What does success look like for you?
Um, Building things with amazing people around me. I think I always enjoy working with good, smart individuals, and like there's nothing more rewarding than that. And yeah, as a function of that, producing products or solutions that actually benefit people, right? And it's always rewarding to make sure people use your products and your technology, and like you're actually making an impact to them, and like to me that's success.
That's awesome. So build something people want and people will use.
Yeah,
That's great.
with good people along the way.
Yeah, of course. Of course. All right, Sergey, man, thank you so much for coming on. I appreciate it. It was stellar. Where can people find you and learn more about Axelar?
Yeah, so you can go to Axelar.network to learn more about Axelar. You can follow me on Twitter. I'm Sergey _NOG.
Amazing. Thank you, sir.
Thank you guys for having me.